Okay, so what we're about to study now is the method of least squares. It's also known as linear regression. So the first few slides are not essential for you to be able to do the problems, but they do help to develop a richer understanding of what we're doing here. So the method of least squares is used for determining the straight line that's really our best line of best fit for a scatter plot. So it's the method of least squares. It's also known as linear regression. So let's say we have 5 data points. So point 1 is x coordinate 1, y coordinate 1. That's just being as generic as possible. And give us, let's say we have these 5 points and we expect our data to be linear. We want to find the best line of best fit. Now we could just try to connect a couple lines or connect a couple points like we did in our previous labs and find the line that goes through those. But the best line of best fit can actually be mathematically found, and that's through the method of least squares. Okay, so when we draw our best line, there's these little differences in the distance. So here's our line that's supposed to model our data, and this distance is called a residual. This distance is different for each point, and what we want to do is the method of least squares takes into account all these distances, so from the point to the line, point to the line, point to the line. And what it does is it wants to make each of those distances, if you square them and then add them, it wants this whole number to be as small as possible. Okay? So it turns out that when you do that, for all the points, to get your linear function, this needs to be true. You go to what's called two normal equations. Okay, so they look kind of crazy. Let me try to simplify that for you a little bit. So basically, we want this is going to be our y equals mx plus b. So we need those two numbers, right? We need our m and we need our b. Not a good color. We need our m, we need our b. So what we're going to do is we're going to make a system of equations where the coefficients are this for the m and this for the b, and this will be a number, number, number. So we have something like 2m plus 3b equals 5. And then you get another coefficient such that this is true, sum of all the squares times m, sum of all the x's, and sum of all the products of x and y. And that'll give us, these three will all be numbers, and we'll have another thing that's kind of like, I don't know, for example, 1m plus 3b, or 31b equals 10. Alright, so now we have a system of equations that we will solve. When we solve the system of equations, we have our m and we have our b, and then we can just plug those into our function for y equals mx plus b. Okay, so let's see an example here. We got 5 points, and we're going to try to find the best line of best fit, the linear regression line, alright, through the method of least squares. So, just so you get a chance to see what it looks like, we have these points, 3, 4, 4, 3, and 5, 6. Okay, so those are our points. Not necessarily all on the same line, but they look like they should be a linear correlation there. So if we draw our line, there's no one line that's going to hit them all. Alright, so that looks like a pretty decent line. Let's see what we get for an equation here. This is how this works. So we want something times x, or something times m plus something times b equals. Alright, so these are going to be the same, and it's just a matter of filling in these spots with numbers. So the first one is the sum of x's, number of points, and the sum of y's. So what we're going to do is we're just going to write all our points here. 1, 1, 2, 3, 3, 4, 4, 3, and 5, 6. So now we're going to add all these columns, and we're also going to figure our x squared, and we're going to total these 4 columns. So our x squared is going to be 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Alright, now we do the product of x and y for each point. 1 times 1 is 1. 2 times 3 is 6. 3 times 4 is 12. 4 times 3 is 12. And 5 times 6 is 30. Alright, now we sum these columns. So you're going to have to make the chart, sum the columns, So what do we get? We get 3, 6, 15. That's going to be 17. This is 20, 30, 55. And this is going to be 30, 54, 61. So now that we have all our totals, we just put them in the right spots. So we want sum of x's, so that's 15. That goes here. And then we want n stands for the number of points. So we have 5 points, right? 1, 2, 3, 4, 5. So that's there. And then the sum of y's is what that equals. Sum of y's was this one here, 17. So it equals 17. Now we want the sum of the x squareds. So that's this. We want the sum of the xy products. Or sum of the x's rather goes here, so that's a 15 again. And then sum of the xy's, and that's 61. Alright, so there is our system of equations. Now all we need to do is solve our system. So I've just pasted that system right here. So I'm going to first solve and isolate the b here. So this gives us, if we subtract 15m from both sides, we have 5b equals negative 15m plus 17. Divide by 5. And we get b equals negative 3m plus 17 over 5. So now we're just going to take this, following the method of substitution, and substitute that in for b here. So we get 55m plus 15 times our substituted in equation, our substituted in expression. So we replaced b with what b is equal to over here. And now we just distribute and solve. So we have 55m So m equals 1. So now we have part of our equation. So the slope is 1. Now we go back in and solve for b. And we get negative 3 times 1 plus 17 over 5, which is negative 15 over 5 plus 17 over 5, which is negative 2/5, or positive 2/5 rather, or 0.4. So that's our b. Alright, now we have our m and our b, right? So y equals mx plus b. So in this case, y equals 1x plus 0.4. There is our solution. That is the best line of best fit that goes through these points. So here we go. This is our solution. Now I want you guys to try one. So remember, given the points, you make this table, find sum of x's, sum of y's, sum of x squared, sum of y squareds. And then all you need is, I'm going to use x's, but these all stands for sums. So sum of x's times m plus the number of points times b equals the sum of y's. And then the sum of the x squareds times m plus sum of x's times b equals the sum of the xy's. Alright, so these are all sums. Now, for your problem, you can read the example. It's in a context. Essentially, all you need to do is use this table and simply answer this question. Find the function. So do the same method with this table here. Alright, see you next class.